6.5, more on division of radical expressions. Radical means it has square roots in it. Okay, so it's an expression, it's not an equation, so it's not going to have any equals. It's just going to be like, how we were adding and subtracting expressions. Now we're just dividing expressions with square roots in them. Okay? So we're dividing square root expressions. Here's an example. Square root of 5 over 3. Okay, first let me ask you a question.
I'm not a blood donor.
I'm not either. I gave all enough blood already. Okay. What happens when you multiply by 1?
It's the same thing, right?
You get the same thing. If you multiply by 1, it does not change. So if we multiply by 1, it's still going to be equal to what we started with. It may look different, but it's still going to be equal. Okay, we're going to end up multiplying by 1 in some way in a minute, okay? What we need to do is what they call rationalizing the denominator. Let me write that down. Rationalize the denominator. Okay? That's telling you to make your denominator, which is the bottom of your fraction, right? That's telling you to make your denominator rational, not radical anymore. That means to make it into a whole number. A number, not a radical. Okay, this is a radical. The bottom has a square root on it. Remember that this can be rewritten as square root of 5 over square root of 3. That's got a radical. We need to rationalize that bottom. How are we going to rationalize it? Multiply it by 1. It's still going to be the same thing, but we're going to multiply it by 1 in the form of something over itself. Remember when you did something, a square root times that, it came out to a whole number? Okay, let's multiply by 1. This over itself. Now we have a rational denominator. We just rationalized the denominator. The top, square root of 5 times square root of 3, remember it's square root, multiply what's on bottom. You cannot simplify that any farther. You can't divide that.
So that's the answer?
That is the answer. Okay, let's rationalize another problem. We have square root of 8 sevenths. So that's the same as square root of 8 over square root of 7. Okay, you can go ahead and simplify the top if you would like before you rationalize the denominator. If you see something that you can simplify, you can go ahead and do that. We still have square root of 7 on the bottom. This is square root of 4 times square root of 2. We haven't started rationalizing yet. We have 2 square root of 2 on top now. Now I want to rationalize the denominator. How are we going to do that? What are we going to multiply by?
7 over 7.
Square root of 7 over square root of 7, yes.
That was implied.
Yes, that was implied, but it was not said. Okay, so this comes out to 7. This comes out to 2 square root of 14. You didn't have to do this first. If we had started off right away by going square root of 7, you would have had the 7 on bottom. The top would have been 8 times 7. You had square root of 56. It still would have turned into this. It just would have been a little more complicated maybe to figure out how to simplify it. So if you simplify first, it might make your life easier. Not that I can totally simplify your life, but maybe it'll make it a little easier, and we'll all be happy and everything. Well, maybe not, but can't make everybody happy. Okay, let's do another one here. 2 square root of 3 over 7 square root of 5. Okay, I don't see anything we can simplify like we did the square root of 8. So, no simplifying. Now, when you multiply the top and bottom to rationalize, you don't have to multiply this whole thing. This is already rational. The only thing you need to rationalize is this part of it. So we're going to multiply only by the part that we need to rationalize, the square root part, the radical. Okay? All we want to get out of the bottom is that square root. So, on top we have 2 square root of 3 square root of 5 is square root of 15. On the bottom we have 7. What is this? 5. 7 times 5. So that's 35. Okay, right here, you can look to see if there's a way to simplify it. Okay, if this had been a multiple of 5 or 7, we could have simplified this part. You cannot do this part, the square root and the number. You can't do any canceling here. So this cannot be simplified any further. Okay, let's do a cube root. Cube root of 7x over the cube root of 3y. Okay, now we need to make it where these are both perfect cubes. So we need to multiply by something. It'll be a cube root of something. The y, we need 2 more of them, right? To have y cubed, so it'll come out. 3, we need 2 more 3's. 3 times 3. We need 9. Because we need 9 times 3 is 27. That's a perfect cube, right? So now that we figured this out, we're going to do it on the top and the bottom. Same thing on the top, because we're going to multiply by 1. The bottom, it should all come out, or we messed up. The cube root of 27 is what? 3. This comes out as 3. The cube root of y to the 3rd power comes out as y. Now we have a cube root times a cube root, so that's still going to stay under here. Okay, 9 times 7, 63. And instead of worrying later, are we going to be able to divide this where there's a perfect cube? This is not going to come out. That wouldn't come out. So this is not going to be able to break down into any perfect cubes. So you're not going to have to worry about breaking it down to simplify that further. The x and the y squared, they just have to stay separated right there. And that's as far as you can go. We can't do any of this canceling because this is under cube root and this is not. If there was something in front, you might be able to. You can't do this because this is not under a cube root and that is. Okay, new problem. Let's do another cube root one. 2y to the 4th, cube root of 2y to the 4th, cube root of 6x to the 4th.
Times the cube root of 36. Right?
Right. Because this is a 3 and a 2, so yeah, this is one of these, you need 2 of these, 6 times 6. And we need this exponent to be a multiple of 3. So if you have 4 of them, you need 2 more to make it 6, where it'll be a multiple of 3. Okay? And this one, oh, sorry, we have to do that, the same thing on top and bottom, right? So, let's multiply. 36 times 6 is 216, I think. Okay, and the x's will be x to the 6th. Okay, the top, 36 times 2, 72. And 2 x's and 2 y's, I'm putting them in xy order. Okay. And I'm going to rewrite this, bring it down here to work with it. So we don't have to keep looking up, oh, sorry. Don't have to keep looking up there for our problem. Okay, where did oh, I got rid of it. My cubes. One more cube. Okay. And add one to this. What is 6 times 6 times 6? 216? 36 times 6 is 216. So this part's going to come out as a 6. The cube root of this is 6, right? That's why we made that number. We wanted it to come out. So 6 comes out. X to the 6th. That's x to the 3rd times x to the 3rd, right? So this one comes out as an x, and that one comes out as an x. So you have an x and an x coming out, x squared. Or you could say this is x to the 3rd, no, x squared cubed. See, the cube part goes away, you have x squared coming out. So there's a couple ways you could figure out this is going to be x squared. You bring one x out here, and another x out is 2 of them. Or you can say it's squared to the 3rd power. Okay, so the bottom's done, right? We've done that. 72. I think we can probably find a cube in there. What we could do is break it down into primes and we'll see if there's 3 of any of the factors. So 72, let me see, let's do it here. 72 divided by 2 is 36. Divided by 2 is 18. Yeah, 2 will come out, huh? Divided by 2 is 9. 9 is only 3 times 3, so no big deal. So we've got 8 times 9. Or we could have looked at our cubes and saw that 8 divided into it, right? That would have been easier. So we have the cube root of 8 times 9, x squared, that's fine. This one, there's a 3 here, and 1 more left over. I broke that all the way down, so we could do one step just by doing one thing at a time, okay? So we're going to bring it down here. Cube root of 8 is what? 2. That's coming out. That will come out, that will, the y will come out, so leave room for a y there. Okay. This came out as 2, the 9. These are cube roots, not just a square. Cube root of 9. That's going to be 9. Just make a big mess. And the x squared cannot come out, so we leave it under there as x squared. The y cubed will come out as y. 1y stays under. Is there anything we can do to simplify that? Can't do anything under here. If you had that over that, would you be able to reduce anything? The numbers or the letters? Look at the numbers. 2 and 6. Will they divide by 2? You can do that. Divide by 2, divide by 2. Okay? So y is in the front, cube root of 9x squared y over 3x squared will be your simplified form. So if you had put this in your math lab, it would have said, yes, this is equal to the answer, but don't forget to simplify. Okay? It would give you some kind of message like that. Okay. Another one, and then we're going to move into conjugates. Well, maybe 2 more. Let's do this for sure. 1 over 4th root of st. This one should go pretty fast. What are we going to multiply to make it where they're all 4th powers that will come out? The s we're needing 3 more, and the t we're needing 3 more. We have 1, we need 3 more, right? So the top 4th root of s to the 3rd, t to the 3rd. So on the top, 1 times that is that. And we have 4 s's here. 4 s's will come out as 1 s, right? Because it's a 4th root. So we'll have 1 s. And 4 t's will come out as 1 t. And you can't cancel inside and outside. Let's do where there's not a variable on the bottom. Let's do 20 or something like that. Let's do square root of 3x over 20. You can, what do you call it? You can simplify this by doing the 4 and 5, but if you'd like, you just do square root of 20 over square root of 20. That would be my simplest way I would go about it, we'll simplify it later. Let's go ahead and just put times square root of 20, square root of 20. And this has a square root over both of them that can be divided out, broken down into square roots. Square root of 20 over square times square root of 20 is 20, right? Square root, everything under that will turn into 60x. Now we can break 60 down into perfect squares. What will go into it? We know for sure 4 will. Is there anything bigger possibly? What is it? 4 times what? 12? 16? What? 15.
Yeah.
Okay, 15 is not going to break down into anything else. So we're going to break this down into 4 times 15. Okay, this will come out as a 2, right? Square root of 4 turns into 2. This stays under. Can we reduce that? Yes, because I didn't simplify the bottom before I did this. So you're going to end up reducing it at the end. So the answer will just be square root of 15x over 10. And remember, you can't divide inside the square root and outside the square root. Okay? Now we're going into conjugates. We are still rationalizing denominators. We're just having to go about it in a little more complicated form. Okay, and we're going to leave during the introduction of it so we come back all confused. Okay, 6 minus square root of 10. I can't stop. We don't have that many minutes to stop. Okay. We need to multiply by something that will get rid of this. You cannot just multiply by square root of 10. Because if we multiply this times square root of 10, that would make this still be a square root of 10 that stayed under there. Okay. Go back to our lecture that we just did, and let me remind you what happens when you have things like this. Remember, these are difference of squares. So if you were given this and you multiplied it by this, you don't have any more square roots, right? So if it had a plus, stick a minus and leave those exactly the same. If it had a minus, stick a plus there, leave those exactly the same. So we're going to leave these exactly the same and change the sign. And that's going to get rid of every square root in the bottom. We have to do that on top and bottom. Can't just do it on bottom and not the top, right? So when we do the bottom, remember what we had? We squared this. It was the difference of squares. We squared that minus squaring that is 10. Right. Now we actually have to distribute this. 9 times 6, 54, plus 9 times square root of 10. Okay, so this can turn into 36 minus 10 is 26. Okay, now be careful before you answer this question. Okay, can we reduce? Okay, it looks like automatically you would say, oh look, this divides by 2. But remember that you cannot, if this has a plus or minus here, you can't just cancel parts. It has to be something factored out to be reducible. Okay? So you can't do just a part of this. If you could factor 2 out, then you would really divide by 2 or something. Okay? So that is as far as you can go on that. Okay. Let's do another one. 3/8 plus square root of 5. Okay. What's the conjugate of 8 plus square root of 5? What is it?
8 minus.
Minus. So we need to do that on the top and bottom. The bottom turns into this squared, which is 64, minus, remember it's the difference of the squares. So that squared minus this squared. This squared is what? Square root of 5 square root of 5 is 5. Right. Now we're going to distribute. 3 times 8 is 24. Minus 3 times square root of 5 is 3 square root of 5. Okay, 64 minus 5 is 59. Right? Okay. And then we put this up here. Actually, we could factor 3 out, right? Both of those divided by 3. It's not in the book that way, I guess, because you can't divide by 3. But, I mean, you could divide these by 3, and you'll have, back where you started, I'm sorry, not a square root. You'd have the 8 minus square root of 5 back. Since that won't cancel, they left it in this form right here. If the bottom would have been able to divide by 3, we would have left it out here so we could have canceled with it. If this had been like 60, we would have been able to do some canceling. But in fact, that one, the 9 would have factored out, but 9 doesn't divide by the 26. So that's your answer right there. Don't leave it factored with the parentheses. They don't want parentheses in the top. Okay, let's do one with the square root in the top. -4 square root of 7 over square root of 5 plus square root of 3. What's the conjugate? Minus, leave it, right? Leave it, change the sign. Okay, let's do the bottoms. The square, this is a difference of squares. So we have the square of that is 5, minus the square of this, 3. No high fives. See, you missed your high five you could have done right here. You were almost asleep. Stand up and watch. If you're sitting there watching, stand up and watch. Just as good. Okay, so this times this, -4 square root of 35, right? Is that what you said? No. Yeah, that's what he said. And then, I'm going to start to put minus because I see this minus, but it's going to be negative times negative, so this is actually going to be a plus, right? Square root of 21. 7 times 3 is 21. Okay? 5 minus 3 on bottom is 2. Can we factor 4 out maybe? Sure. Did they?
That's very confident.
Did they? Yeah, they did. I was like, I think they did. Okay, so factor the 4 out. What do you get when you factor 4 out of this? Still have,
Negative.
yeah. You know what, they didn't factor it out though? They just divided each one of these by 2. Well, we can factor it out. We're going to have negatives this plus, no 4 no more, right? Square root of 21. Okay. So we can divide by 2. And then you're going to have to multiply it back. So instead of factoring it and doing that, I'll show you what else we could do. Okay, so this we're going to multiply it. We have negative 2 square root of 35 plus 2 square root of 21. That's the answer they gave. Now let me show you what we're going to do instead of factoring from here. If this is divided by 2, we're going to just divide each one of these by 2, and we can get there quicker. See, this is negative 2, and this is the positive 2 of that. If you're falling asleep, stand up. You're not going to get notes anyway. They'll just help you stay awake. Told you it works. Tape it. Try it. Take it to bed with you.
What?
A tape of my lecture.
Oh, they even take you to bed?
No, take the tape to bed. No. I don't want to freak you out. Tape it and take it to bed. This is the perfect sleeping pill, a math lecture. Okay, let's do just one more conjugate and then I'll let you go.
That's actually true because I was up watching a video and I was
I see it happening. I see it. The lights are dimmed and just my monotone voice is blah, 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 blah. It's like, this is Bill Nye, the science guy. Yeah. I'm sorry. Okay? It's hard to make math exciting. Okay, but I'm trying. I tried really hard. Okay, so we have 6 square root of 3 on top, and it's getting warm. No wonder you're falling asleep. Dang. It is warm in here, huh? I don't usually have to take my jacket off. Okay, 6 square root of 3 over. That makes me feel better. It may not be all my fault. Minus square root of 5. So we got 6 square root of 3 over 3 square root of 2 minus square root of 5. What is the conjugate of this bottom?
3 square root of 2 plus square root of 5.
Plus square root of 5, right. 3 square root of 2 plus square root of 5 on the top and bottom. The bottom is a difference of squares. If you square this, what is 3 square root of 2 times 3 square root of 2?
3 square root of 2.
9. Square root of 4 is 2. So it's 9 times 2. Right? And then difference, that was just the first one squared, minus the second one squared. 5. Okay. All right. And now we have distributing. Okay. This times this is 6 times 3, 18. Square root of 3 square root of 2, square root of 6, plus
6 square root of
6 what?
15. Square root of 15.
6 square root of 15. All right, got that so far. Bottom, we have 18 minus 5 is what? 13. We won't want to put 13 under these to reduce it, right? That's not going to do us any good. These will not reduce down to anything wonderful, so we're going to be done. And I'll let you guys go if you don't have any questions. And look at the time. What timing? Any questions?